Hello class and welcome to our ACT prep. Today we're going to go ahead and look at probability with Venn diagrams, and we're also going to look at weighted averages. Okay, so the first thing we're going to do is just look at a Venn diagram. Okay, so in example 1 we have a Venn diagram. It says in a survey 100 adults are asked whether they like coffee or whether they like tea. The Venn diagram shows the results of the survey. Okay, the biggest thing is if there's 100 adults. Okay, that means that when you take 13 plus 46 plus 25 plus 16, that is going to add up to 100. So when you add all of those numbers together, you're going to get to 100. This C here shows the people that like coffee. Okay, that means that 13 plus 65 people like coffee. So that means that there's 59 people that like coffee. If I look at my T circle, this circle represents T. That means that 46 plus 25 people like tea, so 71 like tea. And then there is 2, the circle where they meet in between. Okay, the circle where they meet in between means that they like both. Okay, they like both coffee and tea. And then the last number we need to talk about is 16. 16 means they don't like coffee or tea. Okay, they like neither. So let's just go ahead and look at some probability problems that do with Venn diagrams. So a person is chosen at random. Find the probability that the person does not like coffee. Okay, so what I would recommend is figuring out, well, how many people like coffee? So who likes coffee? And we already talked about this, but it's going to be that 13 plus the 46. That's how many people like coffee. So there's 59 people that like coffee. The thing is, we want who does not like coffee. Well, there's 100 people, so 100 minus 59 will equal 41. So that means there's 41 people that do not like coffee. Okay. So to figure out the probability of those who do not, well, there's 41 out of 100. 41 out of 100. That's how many people do not like coffee. Okay, the next one we're going to look at is part B. Okay, it says a person who likes tea is chosen at random. So now we're only going to look at the people who like tea for part B. Okay, how many people like tea? Well, 46 plus 25. That's my tea people. It's 46 plus 25. So that means that we are choosing somebody out of 71 people. Okay, or it's our total. So it's a person who likes tea, okay, is chosen at random, so that means our bottom number for our fraction is 71. And we'll find the probability that this person also likes coffee. Well, my people that also like coffee and tea are 46, so it is 46 out of 71. Okay. And then example C says 2 people are chosen at random. Find the probability that they both like coffee. Okay, so we're choosing 2 people at random, so we're looking at everybody again, and we want to figure out that they both like coffee. Well, if you look at part A, we wrote down how many people like coffee, and that would be that 13 plus 46, so there is 59 people total that like coffee, so 59 out of 100. So we're going to find the probability that they both like coffee. So this is the probability that the first person likes coffee times the probability that the second person will like coffee. Well, if I choose this person, I'm not going to choose this person again, so it's going to be 58 people out of 99. Okay? And if you're going to do this on your calculator, okay, you would do 59 divided by 100 times 58 divided by 99. Okay? That's going to give me my answer as a decimal, and you can write that down. I want to show you a trick, though, if you want to convert a decimal into a fraction. You're going to hit the math button, and you guys see how it says frac on number 1? You would hit enter and enter again. So my answer is 1,711 over 4,950. So that will be my answer when I multiply those two, okay, as a fraction. So you want to leave it as a decimal, that is fine. Okay. So this equals, like I said, 1,711 over 4,950. So there is my answer simplified as a fraction. Okay, that is it for what we are talking about for Venn diagrams. Now we're going to go ahead and move on to weighted averages. Okay, so here's an example with a weighted average. The final grade for a class is calculated by taking 75% of the average test score and adding 25% of the score on the final exam. If all scores are out of 100 and the student has a 76 test average, what score does the student need on the final exam to have a final grade of at least 80? All right, so first things first is it says 75% of the average test score. I'm going to put 75 as a decimal, so it's going to be 0.75. And then we're going to multiply it by the average test score, which is 76. Okay, but my test grade or my final grade is not made up of just test scores. It's also worth 25% on the final exam. So plus 0.25. My final exam, I don't know what that is, so I'm going to use X. Okay, and it has to be at least an 80%. So it means I want it to be greater than or equal to 80. Then I would solve. On my calculator, you take 0.75 times 76. That's going to give you 57 plus 0.25x. That's going to be greater than or equal to 80. My next step would be to subtract 57 from both sides. So I'm left with 0.25x is greater than or equal to 80 minus 57 is 23. Now my last step to do is divide by 0.25 on both sides. Okay, I'm dividing by a positive, so I don't need to flip my sign. So x has to be greater than or equal to, on your calculator, 23 divided by 0.25 is 92. So that means that they need to get a 92% on that final exam or higher in order to get that 80%. Okay. So notice on this example, we put the percent that make up the grade as a decimal, and we kept the test scores as whole numbers. Okay, you can do it either way. The next one we're going to put everything into decimals, and I'll show you that you'll get the same answer. All right, so if you see example 3, the final grade for your Algebra 2 class is calculated by taking 70% of the average test score, 15% of the average homework, and 15% of the score on the final exam. And this is actually how we calculate your Algebra 2 grade. So if you want to do this to figure out what you need to get on your Algebra 2 final exam, go ahead. So if Ronald's current test score is 87% and the homework score is 96%, Part A wants to know what does he need to get on a final exam to have a final grade of at least a 90%. All right, so 70% average test score. Well, my average test score is 87%. Okay, so I would do 0.7. To represent 70%, and I'm going to put this as a decimal, 0.87. Plus, the next thing we have on here is homework. The homework's a 96, so it'd be plus 0.15 times my homework, 0.96. Plus, now this one has 3 categories, 15% on the final exam. So 0.15, my final exam, I don't know what that is. So x, and then I want it to be at least 90, so it has to be bigger than or equal to 0.9. So you can do that. This one is, everything is in decimals, so you can do it this way, or how we did it in the other one. You could just use 87 here, 96, and 90 if you wanted to. It's totally up to you. Either way is fine. So on your calculator, you take 0.7 times 0.87, and this is going to go ahead and give me 0.609 plus 0.15 times 0.96 is 0.144 plus, I'm just recopying this piece down. Now I'm going to go ahead and combine my like terms. So if I add these two together, I will get 0.753 plus 0.15x is greater than or equal to 0.9. So now I go ahead, I subtract 0.753 from both sides because I'm solving for x. So I have 0.15x is greater than or equal to 0.147. You subtract those. Now I'm going to go ahead and divide both sides by 0.15. So x is greater than or equal to, if you do this on your calculator, you get 0.98. Okay, well, it has to be greater than or equal to 0.98. Well, what that really means is 0.98, if I move it over 2, it means that it's a 98% or higher. Okay, so if Ronald wants to get a 96%, he has to get a 98% or higher on his final exam. Okay. The next one we're going to go ahead and look at is still Ronald's problem. But now I want to know, okay, if his current test score is 87%, okay, and his homework's 96, what does he have to do in order to get a 93? So everything in my problem, my original setup, is going to be the same other than what it's going to be greater than or equal to. So let's just set it up. So once again, 70% of the average test score, so it's 0.7 times my average test score, which is 0.87. Okay, plus my homework, which is 96%, plus my final exam is 15% x, has to be greater than or equal to 93. So this is where it's different, so 0.93. Okay, we already multiplied these and combined like terms on the other side. So what I'm really going to have is 0.753 plus 0.14x has to be greater than or equal to 0.93. Okay, subtract that 0.753 from both sides. So I will have 0.15x is greater than or equal to 0.177. If I divide by 0.15 on both sides, I have that x is greater than or equal to 1.18. Okay, now we have to remember, move it over 2. So x has to be 118% or higher. So if he gets an answer like that, okay, that he has to get 118% or higher, and there's no extra credit on his final exam, can he get an A+? No, Ronald cannot get an A+. There would have to be a lot of extra credit, and he'd have to have a perfect score in order to do that. All right, one last example, example 4. Okay, John's college math grade is determined by taking the average of 5 tests. Okay, so once the average of 5 tests. If John got the following test scores, 87, 85, 93, and 88 on his first 4 tests, what does he need to get on his 5th test to get a B, which is an 80%? Okay, well, we're finding average. So remember, average is taking them all and adding them together, dividing by the number of numbers, okay, to figure out the average. So we have 87 plus 85 plus 93 plus 88 plus, there's 5 test scores. I don't know the last one, so plus x. All over the number of tests, there's 5. We want it to equal, I'm going to leave this one, it says 80%, I'm going to leave it as 80. Because I left these all as whole numbers, so 80. Now I go ahead, if I add all of these values together here, on my calculator, I add those together and I will get 353 plus x over 5 is equal to 80. I would multiply by 5 on both sides to solve this. So I have that 353 plus x is equal to 400. I would subtract 353 from both sides. So this will leave me with x, subtracting, is equal to 47. So what this means is that he needs to get a 47% or 47 out of 100. On his test in order to get a B, to keep his A. To keep his B, he needs to get a 47%. So I think he should be able to do that. So if there's any questions, please make sure you write them down. Otherwise, I will see you later and have a great day.